Going live in a second.
It said it's already live.
And let's see. Okay, for those who have better things to do, we've scheduled the after hours for tonight to slightly later hours so that all the professors can show up at once. We'll see. It's either 8:30 or 9, and I can't remember which. So plan accordingly. It's the 14th of March, and welcome to Dis and Dat. I'm going to talk a little bit about Doreen Massey, or Massey, and certain ideas about some of what she's written about. I think in her later life, she talked a little bit more about intersectional elements, that is, space, place, and gender. I'm not going to talk about that. What I am going to talk about is this general idea that comes across generally at the same time as David Harvey starts talking about sort of the same things that are discussed by many other people, the annihilation of space and time, that are very modern ideas, one more than the other, perhaps. But before that, I'm still working on some ideas here, and as you've probably seen in my yammering, that I have something of an idea going on, and it's not so much that I'm casting around for a brandable metaphor, but rather, and with all due respect to qualitative versus quantitative analysis, I think that the way to bridge it is to think not only in general terms or generalizable terms, but kind of at the critical intersections. So, in the same way that we have a kind of shadow, as it were, when we discuss catastrophe theory, similarly, I think we can have some kind of both a qualitative and quantitative discussion that addresses some key elements in amongst these theories. Let's put it that way. And not to reify the anything at this early date, but I'm asking some other kinds of questions that are not only metaphorical, that is, does Illith or Ilth have a diaphanous veil, or and is that veil a real or nominal veil, as in numbers? Do veils define externality in their filtration because there are positive and negative externalities, and further divisions of such ideas? Noting, of course, that this is the difference between the external and the internal, and yes, it does go back to the Hegelian stuff at some moment. So all of these things can work at the same time without saying that everything has to work and that it is, totalizable and blah, 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 blah. But that that there are surfaces for such things or sets for such things, to get even a little further afield or categorical. But anyway, all of those ideas are at work, and I don't find them terribly problematic, nor do I find them ambiguous or confused. I think that as we proceed further, it gets there are numerical solutions for this, as Cockshot did in the video from 2 days ago. The discussion can have a certain quantifiability, even though it seems a little abstruse. Anyway, so we're talking about veils, and so one veil certainly is the veil of ignorance, John Rawls's veil of ignorance, which doesn't relate quite so much, but in a Kantian way, it actually overlaps with a certain idea about cooperation that we're going to get to eventually, or I will get to eventually. For example, John Romer's work has a Kantian element to it that I think is worth thinking about in this context. That is, veils of ignorance prevent people from knowing sort of their intersectionality, their social status, their ethnicity, etc. That the idea, the ethical boundaries are sort of an interesting kind of way in which we could talk about certain types of neutrality. Um, and is neutrality impartial? Is neutrality rational? And without getting too far afield, uh, this idea is not problematic. I think it is important that Rawls brings it up. It certainly was problematic when you have Nozick coming up at the same time and blah, 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 all these other ways in which we can configure perhaps the legal element, so the Moshe Pastone kind of issues at work as well. So anyway, needless to say, um, this is a thought experiment. It's a social choice thought experiment, and but it's not simply a social choice experiment. It's not about choice in many ways. So that's where it gets even further interesting from an agency point of view, et cetera. So we're not even that far yet. I think we can get there though. Now, what I wanted to do, because I was, reading Doreen Massey and a bunch of other things on space time, and space time, as the arguments go, and finally wound up on a reference that I had set aside and hadn't gotten back to for a while. But it also reminded me that at some moment, maybe I should go to Sweden. But anyway, it's another story. So there's this article called The Implications of Ecologically Unequal Exchange for Conceptualizations of Technological Development, a critical survey. And like all critical surveys, it has a range of things going on in it, some of which are better than others or more interesting than others. And this particular article by Alf Hornborg um, surveys the emergence of theories of ecologically unequal exchange and outlines the implications of an EUE, an ecologically unequal exchange perspective for a materialist conceptualization of trade and technological development. Noting, of course, that that's the whole business, right? That's the whole second part of talking about Marxian things. It briefly traces the progression of new perspectives and methodologies for identifying EUE, ecologically unequal exchange, from the early 1970s, reviewing the genealogy of concerns with asymmetric global transfers of embodied energies, materials, land, and labor. Now, note, of course, just to phrase it in that way, obviously has some value questions that are obscured by the fictive reciprocity of market prices. This is the core of the whole problem, right? Values versus prices, um, embodiment, whatever that might be, all of that is there. And in a larger theory of ecology, you have to sort of come to grips with it one way or the other. And other metaphors come to mind: seven veils, blah blah blah. All those other things can happen. Trade that is perceived by mainstream economists as balanced in monetary terms may be highly asymmetric in terms of transfers of biophysical resources. This is an equilibrium problem. In other words, can we in fact get to can we generalize in that particular context? And that's the problem that Marx perhaps never gets to, and that many people tried to during the more analytic phase, because I don't, you know, I think it ebbs and flows, the analytic phases of Marxism or Marxian analysis. And as I said, we're perhaps not so much moving past it, but the branding perhaps needs to be set in a different place, simply because the questions are quote unquote much broader, even though they are generalizable. Anyway, contrary to the mainstream view, EUE theory, U theory, holds that the material substance of traded commodities may have a significant implications for the capacity of different geographical areas to accumulate technological infrastructure, achieve economic growth, and displace environmental pressures to other regions or countries. So already you have this something's going on here. Could be, carbon trading or some other kind of element could be built into this. The article argues that such non-monetary transfers. Now, the problem of a carbon market, of course, is that it is about monetary transfer, so that's already problematic. Could be understood in terms of biophysical metrics rather than economic values, shifting the perspective from monetary valuation to the material properties of traded commodities. Now, that certainly is an interesting way to approach it, particularly with base metals, for example. Minerals could be, it's interesting from the minerals point of view because you could say, oh, well, batteries, for example, large scale electric vehicle batteries as being some example of that because you need a whole bunch of different types of metals, including lithium, but at least at this moment. But there's other issues at work. Net transfers of embodied resources through trade do not just represent economic cost shifting, but are physically constitutive of productive infrastructures. So if we move from carbon to hydrogen, maybe, or you really, one has to think about these things in slightly perhaps different ways. This focus on social metabolism, because it implies the social metabolism, signifies an ontological shift from neoclassical to ecological economics. Now, whether you could, state that there is actually a dividing line, because so much of various economics do make decisions about, a market system, price system, blah, 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 blah. The EUE perspective illuminates how modern technologies are no less fetishized than other commodities in the sense that they obscure, and this is that veil thing again, obscure social relations of exchange. It indicates that local technological progress, such as the Industrial Revolution in Britain, may reflect asymmetric global resource flows. And that's automatically, it's almost given, as we were looking at with Brad DeLong's 300 miles from Dover sort of geographical constraint. So let me read part of this article, and then I'll get on to the other yammerings, and I'll stop at my usual time, even though there's a bigger gap between that time and when we're going to do after hours tonight. So warning ahead. Introduction. This article focuses on how research on asymmetric global flows of embodied resources, that is, ecologically unequal exchange, poses a conundrum for the discipline of economics by offering a highly heterodox interpretation of technological expansion. It begins in section 2 with a review of the emergence of the EUE perspective and I'll probably skip that second section, and several quantitative methodologies that have been used by its proponents. The third section discusses how the radical materialism of the EUE approach challenges mainstream as well as Marxian economic theory. The fourth section shows how EUE theory should fundamentally transform our way of thinking about the history of technology. And note, of course, there's the history of technology has several underlying thematic and theoretical ideas built into it. Finally, a concluding section reflects on some of the implications of the argument. Number 2, section 2, the emergence of the EUE approach. The identification and conceptualization of EUE belong within the wider tradition of political ecology, a genre in the environmental social sciences emphasizing interdisciplinary studies of how social power and natural environment are intertwined. Political ecology initially emerged in the 1970s and 1980s among anthropologists and geographers who were dissatisfied with the functionalist assumptions of the school of cultural ecology. It was a very dominant thing. In the 1960s, cultural ecology focused on case studies of traditional subsistence practices in local communities as adaptations to the non-human environment. Pioneers of political ecology, such as the anthropologist Eric Wolf and geographers Harold Brookfield and Piers Blakey, rejected functionalism and instead emphasized the role of power inequalities and global political economy in shaping human environmental relations. They emphasized that the local resource flows studied by cultural ecology were connected to the asymmetric metabolic flows of the world system. Just signifying world system has a whole nother set of things right attached to it. However, they did not at the time have access to the requisite data or the methodologies to substantiate such claims, as the computer turn. The concept of ecologically unequal exchange represents the convergence of two separate strands of research from across the divide between social and natural sciences. In the social sciences, Emmanuel's identification of unequal exchange was embedded in the theoretical framework of the Marxist theory of value. It was thus presented as an asymmetric transfer of labor value from low wage to high wage countries. At roughly the same time, natural scientists were beginning to focus attention on the uneven flows of natural resources, such as raw materials and energy, through modern economies. The systems ecologist Odum presented a model for understanding social and economic processes in terms of flows of embodied energy, already, an issue, I suppose. He coined the notion of emergy, neologisms, as shorthand for embodied energy, but later redefined it as energy memory and explicitly claimed that it was a measure of economic value. This is in the 1980s. Using the analytic framework of world system analysis, yes, that's already signified there, right? Wallerstein, etc., the sociologist Stephen Bunker applied the concept of unequal exchange to asymmetric flows of energy, but he presented his intervention as a modification of classical Marxist theory by approaching energy as an unpaid natural value complementary to labor values. Now, a few years later, Lonergan observed that the theories of unequal exchange based on labor and energy theories of value are analytically very similar. In both frameworks, inequalities are conceptualized as deviations of market prices from real values. I think you can see where this is headed. Whether conceived in terms of embodied labor or embodied energy. Odum and Arding in 91 pioneered the quantification of such assessments by proposing that the export of shrimp, right, from Ecuador to the US represented a measurably unequal exchange of embodied energy between the two countries. You can see all kinds of possibilities there relative to fisheries research. Odum's methodology for assessing such inequalities in international trade focused on the amount of energy that, on average, was purchased per dollar exchanged between two countries. So you see, this is what we see here is exactly the issue. That is, trade occurs, but then the values exchange, the kind of reconciliation of value, is a way to provide a measurement of the differences. An important but often neglected consideration in the conceptualization of EUE is the logically inverse relation between productive potential and economic value, as revealed by Georgescu-Roegen's foundational observation in 1971 at production processes generating an increase in utility, that is, economic value, simultaneously imply a dissipation of energy and matter. For example, an increase in physical disorder or entropy. Rather than to suggest a derivation of economic exchange value from some biophysical input such as labor or energy, as in Marxist and other heterodox value theory, we need to understand, and this is the key point here, the physical consequences of the production of value. Namely, that the market exchange of finished industrial products for fuels and raw materials will inexorably reward the dissipation of natural resources in core areas of the world system with economic access to more resources to dissipate. Now, I know that's kind of a jumble there, but in other words, economic growth means that the more resources the core has dissipated today, the more new resources it will be able to dissipate tomorrow. Moreover, the core tends to use the periphery not only as a source of resources, but also as a sink for its entropy in the form of pollution and waste. And you could say that pollution trading has exactly that issue at work, even though no one wants to talk about it enough. The EUE approach, broadly defined, is inspired a variety of quantitative approaches. Wackernagel and Rees showed that consumption patterns in wealthier countries imply a quantifiable appropriation of embodied, ecologically productive land, ecological footprints from other countries. Applying the ecological footprint measure Andrew Jorgensen and James Rice have identified empirically EUE by tracing how wealthier nations appropriate environmental space from less wealthy ones, for instance, through deforestation, and that's a tremendous literature. Fisher, Kowalski, and Haberl have developed methods for translating statistics on international trade into flows of embodied matter and energy, which have been foundational to studies in industrial ecology and global resource use, as well as to estimates of the physical trade balances, PTB, of nations. As predicted by EUE theory, the PTB, the physical trade balance, tends to be positive for most European nations. Now, but negative for most nations in South America. And so there's, literature for it. And there's a comment, the 8 articles in this special issue of the International Journal of Comparative Sociology cover a wide range of global environmental inequalities generated by international trade, including the geographically skewed impacts of specific types of energy use, biodiversity loss, climate change, and other biophysical consequences of economic processes. Particularly noteworthy is the inclusion among EUE phenomena of climate change, which highlights the urgency of and the relevance of EUE theory for grasping the biophysical features of global social metabolism. The concept of carbon footprint illuminates how greenhouse gas emissions are embodied in commodities and transferred through international trade. The impact of trade on biodiversity loss has similarly been explored in terms of the biodiversity footprints of nations. A special issue of the Journal of Political Ecology was devoted to various concepts and methodologies arriving from relevant to the EUE approach, etc., including calculations of environmental load displacement, embodied human appropriation of net primary production, God, acronyms, life cycle analysis, and ecological debt. Drawing on databases on international flows of raw material equivalents and embodied energy, embodied land, and embodied labor, it's impossible to show that established core regions of the world system in 2007 were net importers of all of these kinds of biophysical resources, empirically confirming the theory of this asymmetry, EUE. A recent and more comprehensive study has seen this, applying to high and low income nations. Another approach is to calculate unequal flows of both embodied labor time and natural space in international trade. And this is actually a kind of has interesting possibility because of some quantitative possibilities there. This approach has been particularly useful in historical case studies where extensive data sets are not available. Studies of Britain's overseas trade in 1850 reveal how the British cotton textile industry at that time relied on asymmetric transfers of embodied labor time and embodied ecological space appropriated from its former colonies in North America. This is the slave trade, right? By the triangle trade, by estimating the quantity of labor hours and hectares of land required to produce 2 volumes of commodities that at a given point in time are equivalent in terms of exchange value, it is possible to assess whether the exchange of those commodities at that time would have entailed an asymmetric exchange of embodied labor or land. This is an interesting, calculable model, perhaps. This method for calculating EUE, referred to as time-space appropriation, has been applied to other societies in historical contexts. It provides a methodological bridge between quantitative ecological economics and historical research, emphasizing the roles of asymmetric resource flows in world history. So you can see that, we've come a fair way from center periphery, core periphery models, and perhaps something that actually is more measurable rather and gives us a kind of a handle on that fundamental issue that some people rely on Marxism for, and that is expropriation or exploitation or alienation or whatever. The common objective of all these efforts has been to reveal material asymmetries in the world economy that tend to be obscured in mainstream economic accounts. And, that's pretty obvious, right? The victors get to make up the numbers. And you can see that input, output, sort of the data becomes fuzzy when it just is numbers. This brief review is aimed to illuminate some foundational contributions to the emergence of this concept, the EUE, but the burgeoning literature is currently expanding in various directions, and it necessarily crosses conventional boundaries between social and natural sciences, drawing on perspective that's widely separated as history and thermodynamics, but not so wide. I was talking with that Coke shot idea there, right? He was talking about Markovian Markov numbers in history. So it's not too far. And Farhoon and Markover, there's stuff there, stuff we can think about as big and ponderous, like Anwar Sheikh's work, etc. I think there's ways of putting these things together. Drawing, as we've seen, on a range of methodologies based on non-monetary metrics, it focuses on asymmetric transfers of embodied biophysical resources and risks obscured by the apparent reciprocity of monetary transactions. And in fact, to use both the biophysical resources and the risk sort of data, can be an interesting idea. It seeks to reveal what is concealed under the veil of market prices. So we're back to veils again, right? Section 3, the EUE perspective as a challenge to economic theory. The discourse on ecologically unequal exchange poses a challenge to economic theory and prompts us to revisit the history of economic thought. The zero-sum doctrine of mercantilism, centrally concerned with the national accumulation of bullion, gold bullion, dominated European colonialism until the late 18th century, where cornucopian arguments for free trade heralded the turn to economic liberalism. Manchester, right? Already when Smith published his volume on the Wealth of Nations, however, the concept of free trade served as a mystification of unequal exchange, as it always does. The obsession with abstract exchange values, hypothesized as money, obscured the flows of real material resources that were embodied in, i.e., had been used in producing the traded commodities. That's the textile industry, etc. This means that market exchange was an ideal social arrangement for organizing systematically asymmetric transfers of embodied biophysical resources, including labor time, without making the asymmetries apparent to the participants in the exchange. That's the entire ideological framework, right? A prime example is the import of plantation produce to Great Britain in the 1770s, which represented significantly greater volumes of embodied land and labor than were embodied in the industrial exports for which they were exchanged. This means, of course, we've got to go all the way back and start looking at these arguments again, some of which are quite, dense with lots of econometric stuff in them, but sometimes it is garbage in, garbage out. Similar observations can be made, for instance, regarding the British import of bar iron from Sweden, which on average in the 1760s represented the annual growth of over 1 million hectares of forest and almost 14,000 person-year equivalents of labor. The divergent assessments of international trade based on monetary or biophysical metrics, respectively, can illuminate the contradiction between antithetical perspectives on economic history that variously describe urban centers of economic growth as, quote, value-adding machines or parasites living off their hinterlands, and attributing a monetary value to all things and making their price a primary aspect of their definition, the phenomenon of money has enveloped the world in a veil of quantitative abstractions that obscures its metabolic materiality. That's a nice little phrase. The general invisibility of this reliance of modern technological society on unequal exchange can be referred to as, quote unquote, machine fetishism. Machines, and you can see that in Marx as well, machines, and we're getting onto that in our reading of Volume 1. Machines, in both in being both material and social, disrupt the customary distinction between nature and society in modern thought. Modern technologies are thus as paradoxical a phenomenon as the money that makes them possible. In organizing and obscuring social transfers of biophysical resources, money blurs the boundary between the social and the natural. Enabled by money, modern technologies represent the interpenetration of social organization and the laws of physics. Because it ultimately rests on human perceptions and beliefs, money, through technology, i.e., capital, thus it challenges Enlightenment convictions by mixing the subjective and the objective. The concept of fetishism is widely used in the sense of mystification, denoting situations where unequal social relations are being obscured. The EUE perspective prompts us to rethink what it is that the fetishism of money and machines obscures. Marx established the heterodox conviction that monetary measures such as wages and prices mystify more essential transfers of labor value between market actors. The EUE paradigm challenges how such non-monetary transfers are conceptualized in heterodox economics and argues that a genuinely materialist perspective should focus on their physical aspects. In conceiving exploitation in terms of value, Marxian economists paradoxically remain confined to the hegemonic worldview of mainstream economics. The value of labor is finally conceptualized in relation to the market price of its product, which reflects the extent to which production has been mechanized. Indeed, the only metric with which labor value can be approximated is money. Marxist analyses of transfers of surplus value aim to calculate the monetary worth of underpaid or unpaid labor, contending that this discrepancy between cost and productivity of labor should be understood as the share of the product price that is claimed by the capitalist. Now, counterintuitively, we must thus conclude that a foundation of Marxian value theory is monetary valuation. This is clearly also the case in Emmanuel's Marxian analysis of unequal exchange and international trade, in which he refers to disparities in wage levels between different countries as the explanation of asymmetric transfers of value between nations. Well, yes and no, considering that there are differentials in, costs of living and blah, blah, blah. However, the understanding of unequal exchange between nations exclusively in terms of transfer of unevenly priced labor has raised questions about asymmetric flows of other kinds of resources, such as energy and materials. Now, people have been actually studying this before, so it's not something that was truly neglected. But anyway, the growing attention to global patterns of ecologically unequal exchange in focusing on the biophysical metrics has highlighted the limits of a focus on labor value. The acknowledgement of asymmetric transfers of non-human energy, materials, and embodied land must imply a shift towards a genuinely materialist account of global social metabolism. However, efforts to liberate economic thought from the hegemonic focus on monetary flows often run into conceptual constraints. Now, this can be exemplified by prevalent assumptions about value. At first sight, definitions of unequal exchange based on underpaid values may seem indistinguishable from the identification of asymmetric resource flows outlined above. But the difference is important. It is untenable to posit the existence of material values that are not recognized by the market actors who negotiate the exchange rates. Now, that's an interesting question. Economic values are determined by humans based on their preferences and assets. The material resources that are asymmetrically exchanged on the market should be conceptualized precisely as material resources rather than as values. Regardless of whether it derives from human labor, draft animals, or fossil fuels, energy is not a value. Notions of underpaid material use values and natural values, quote unquote, confuse the physical and the economic. The inclination of some ecological economists to equate energy and value has been as misleading as the Marxian distinction between them has been ambiguous and contradictory. The struggles of Marxian and ecological economics to conceptualize how market exchange orchestrates asymmetric material transfers are based on legitimate intuitions about the causal entanglement of money and energy. But the assertion that labor power and other forms of energy represent underpaid values is analytically flawed. And that's probably the money shot of this article. The significance of asymmetric transfers of material resources is not that they represent underpaid values, but that they contribute to the physical expansion of productive infrastructure at the receiving end. The accumulation of such technological infrastructure may yield an expanding output of economic value, but this is not equivalent to saying that the resources that are embodied in the infrastructure have an objective value that exceeds their price. The conceptual framework of EUE theory, as defined here, must be distinguished from the proposals within some Marxist and ecological strands of economics that unequal exchange should be understood in terms of asymmetric transfers of quote unquote value. Such definitions of unequal exchange, whether based on labor or energy theories of value, arguably insert a moral judgment into the theory, implying that extractive zones are by definition exploited by industrial centers. Now, this view is difficult to reconcile with the experiences of countries such as Canada or Australia, which have not been impoverished by their net exports of resources. Only by abandoning the morally charged concept of value and instead focusing on net transfers of biophysical resources is it possible to analytically separate EUE and impoverishment and to observe that the former may indeed often contribute to the latter, but does not necessarily always do so. The pervasive aspiration to translate multidimensional commodity flows into a single metric has inspired attempts to quantify EUE in terms of a monetary drain from the global south. Now, although this is indeed a case of massive cost shifting, a materialist approach to EUE cannot be confined to highlighting the monetary dimension of world trade. References to environmental costs give the illusory impression that ecological degradation can be assessed in monetary terms. Similarly misleading is the intimation that the main implication of EUE research is that the global north saves money by shifting costs to the global south. The asymmetric transfers of embodied energy, materials, land, and labor to centers of accumulation do not just represent a systematic cost shifting by these centers, but are physically constitutive of their productive infrastructures. That's why I think we should look more at BRICS, for example, BRICS. In augmenting their output of market commodities, these technological infrastructures generate increasing quantities of exchange values, i.e. money, into such areas, which in turn expand their claims on the resources of other areas. As we shall see, the EUE perspective has very material implications for how we ought to conceptualize technology. To grasp processes of ecological deterioration and climate change, we urgently need to recognize the interaction of economy and material metabolism. Rather than conceptualize such physical processes as quote-unquote market failures and externalities that are redeemable in monetary terms, even though they do help at one level, we must acknowledge the limits of mainstream economics and embrace the transdisciplinary insight that money cannot compensate for entropy. The asymmetric transfers revealed by studies of EUE should be conceptualized as unequal flows not of economic values, but of embodied biophysical resources measured in joules, tons, hectares, and labor time. To posit the occurrence of EUE, and there's indexicality there somewhere, to posit the occurrence of EUE in international trade is not in itself a normative or moral statement, but a conclusion based on empirical methods for assessing the biophysical substance of commodity flows. It means demonstrating that trade perceived by mainstream economists as balanced in monetary terms may be highly asymmetric in terms of the transfer of embodied biophysical resources. A central challenge is to account for the invisibility of EUE in mainstream interpretations of development in the history of economic thought. Whereas earlier economic schools had been concerned with the physical substance of trade, such as its demands on land, the physiocrats obviously, labor, that is the classical political economy, Marx, Smith, and Ricardo, and materials, the mercantilists, such concerns were largely abandoned in modern theories of international trade. Well, that's because of neoclassical econ. But anyway, In focusing exclusively on monetary values and market dynamics, neoclassical economics discarded even the possibility of identifying physical asymmetries in exchange. It's too messy. It is significant, for instance, that Krugman and Wells' monumental volume, Economics, featuring a 27-page, 4-column index, does not even mention unequal exchange. Ooh. The conceptual and structural conditions of this shift of perspective should no doubt be understood in relation to the turn to fossil energy, which was conducive to a cornucopian image of unlimited economic growth, drill baby drill, but rather than viewing growth as based on a Promethean understanding of technological progress, an EUE perspective implies that growth and technological advance may be based on global social processes with some features of a zero-sum game. Now, that actually is quite important. However, the theoretical implications of understanding modern technological systems as global social phenomena have generally not contaminated mainstream conceptions of technologies as innocent manifestations of enlightenment detachable from the social context in which they've emerged. The anthropologist Maurice Godelier argued that even in the most severely stratified societies, unequal exchange tends to be represented as a fair exchange, as reciprocity. Economic anthropology has shown that humans all over the world are concerned with reciprocity. The Maori native, who in 1909 gave us the classic account of the spirit of the gift, as Mose shows in 1925, exemplifies the widespread conviction that human exchange ought to be reasonably balanced, right? This is the veil of ignorance. To systematically appropriate other people's labor or resources is generally perceived as morally unacceptable. Yet the history of civilization is arguably the story of increasingly more sophisticated ways of doing precisely this. That is, appropriating other people's labor and resources and developing worldviews to justify it. That's right. The Ukrainians are not using all their minerals. Such cultural rationalization of inequalities is not to be understood as a malicious intention to conceal injustices, even if it is, but as largely subconscious processes that are opaque to the participants themselves. The very fact that so much cultural effort is invested in obscuring the arbitrariness of inequality suggests that significant asymmetries in human societies need to be morally justified. Coercion was not enough to maintain slavery or serfdom. These material systems of appropriation also required their supporting worldviews, such as racism, medieval theology, respectively. EUE research suggests that mainstream economics similarly, if inadvertently, has the effect of rationalizing global inequalities today. It also suggests a rethinking of the ontology of globalized technologies, which often amount to social strategies for saving time and space for some people at the expense of time and space lost to others. If Godelier's observation is taken seriously, the appearance of reciprocity projected by market prices can be understood as illusory. Mainstream economics in the late 19th century, at the height of British colonialism, abandoned concerns with the material substance of exchange in favor of an exclusive concern with market equilibrium. Economic doctrines on international trade, whether advocating free trade or protectionism, have since then discarded unequal biophysical exchanges. The only use mainstream neoclassical economists after the marginalist revolution could find for the concept of unequal exchange was when market mechanisms were somehow distorted, as in monopoly. Only Marxists and some ecological economists have retained the definition of unequal exchange as an asymmetric net transfer of material resources, such as embodied labor, land, or energy. For mainstream economists today, such asymmetries are difficult to conceptualize. What is arguably the main source of inequalities in our modern world is thus subconsciously kept outside their discursive field of vision. The appearance of economics having abandoned morality is ultimately a result of the fact that it's abandoned concerns with the materiality of the world. Well, yeah, a discipline unable to see the asymmetric global flows of embodied energy, matter, labor, and land is unable to see how market exchange can obscure inequalities. Number 4, rethinking the history of technology. The acknowledgement of EUE has more far-reaching implications than is generally recognized. Rather than being content with accounting for economic and environmental inequalities and injustices generated by systematic cost shifting, research on EUE suggests a radical ontological shift from neoclassical to ecological economics, and the insights and to the insights of environmental sociology. Instead of understanding world trade and economic development in terms of flows and accumulation of money capital, the EUE perspective focuses on the material features of global social metabolism. This is the same global social metabolism that Bellamy Foster is talking about, remember. It denotes the typically urban concentration of metals, oil, cement, timber, agricultural crops, workers, and other physical resources that are required for the reproduction of an advanced technological infrastructure. Such concentration on material resources is clearly the flip side of an accumulation of money, which is essentially the capacity to make claims on other people's labor and resources. But the focus is shifted to what this material process ultimately signifies if analytically isolated from the flows of money. It's a stock flow problem, if in one crude way of thinking about it. And anyway, beyond the immediate acknowledgement of abysmal gaps between incomes, consumption levels, and ecological footprints in different parts of the world, a materialist approach should recognize that what Marx observed about commodity fetishism is equally valid for technological artifacts. Yeah. In other words, the technical objects that are amassed in the global north, cell phones, are no less fetishized than other commodities in the sense that they obscure the global social relations of exchange to which they owe their existence. Technological fetishism is a subcategory of commodity fetishism. As Marx incisively observed, objects that are contingent on social relations may be perceived as autonomously powerful or productive. His classical definition of fetishism is that social relations between people are represented as relations between things. EUE theory now permits us to see machine fetishism and the celebration of ever-rising productivity in industrial core areas as a paradigmatic example of this very phenomenon. The implications of the EUE perspective should prompt us to revise conventional accounts of technological development. It means, for instance, that the celebrated breakthroughs of the Industrial Revolution in 18th century Great Britain should be reassessed in relation to the asymmetric flows of embodied labor and other resources that at the time constituted the capitalist world system. And, of course, that the technological dominance of powerful nations today is similarly founded on unequal exchange. Yeah, peace in Ukraine, for example. Although it raises bewildering questions about what kinds of technologies are morally defensible and about how world trade could possibly be regulated to avoid EUE, the ontological shift toward a consideration of global social metabolism may be more readily accepted today than a few decades ago. The context of potentially disastrous climate change and ecological devastation has made many of us committed to a faith in the progress of modern civilization than were previous generations. Well, maybe. The seemingly inexorable rise in greenhouse gas emissions is difficult to handle for neoclassical economics, Nordhaus, but completely predictable from the perspective of ecological economics. That's the kind of the keen critique of Nordhaus. The CO2 emissions represent entropy, that is, physical disorder generated by the metabolism of the global fossil-fueled infrastructure. As Nicholas Georgescu-Roegen observed more than 50 years ago, the expanded production of economic exchange values promoted by neoclassical economics must correlate with an expanded production of entropy. A corollary of this observation is that the aggregated outputs and waste of an industrial infrastructure will actually have greater entropy than the total entropy of the less valuable inputs. This regularity applies also to the social metabolism of the global north, taken as a whole. Its products and emissions represent more entropy than its inputs. The general pattern documented in EUE research can thus be phrased in terms of the inevitable thermodynamics of the world market. The resources embodied in imports to the global north represent less entropy than the exports for which they are exchanged. The history of human energy use is generally presented as a progression in engineering knowledge based on a succession of discoveries and inventions. And see the note here that Smile or Smeal is quoted. This is undoubtedly a necessary condition for technological progress, but not a sufficient one. A conclusion from EUE research is that the global social aspects of energy transitions may be no less significant than the technical knowledge. This is the transitions issue is actually a key element. Um, The concept of technological progress is conventionally viewed as a matter of local ingenuity, while the global patterns of distribution to which it's often connected are generally ignored. The turn to fossil energy in early industrial Britain, for instance, tends to be attributed exclusively to the invention of the steam engine rather than to the economic incentives to engage in various strategies of environmental load displacement and EUE that made it possible. Now, what that means is other kinds of inputs, water supply, coal production, the manufacture of precision parts or more precision parts anyway, etc. Um, the intensified exports of textiles and other products from Britain in the 19th century granted the country access to vast amounts of land, labor, and materials in its periphery. This embeddedness of steam technology in the structure of the world system can serve as a point of departure for examining more recent technologies in terms of their dependence on global processes of EUE. The use of fossil energy has alleviated pressures on European environments for over 2 centuries, regardless of where the fossil fuels are extracted. Moreover, the global north's imports of fossil energy can also be seen as an environmental load displacement to extractive areas in the Middle East, Africa, and South America. The contemporary vision in Europe and elsewhere of a post-carbon economy has grown out of the twin threats of climate change and peak oil. But it represents a difficult impasse for the mainstream worldview that was consolidated in the 19th century. To replace the dependence of modern society on concentrated subterranean energy deposits representing hundreds of millions of years of solar radiation with reliance on the capacity to harvest current flows of such radiation through renewable energy resources remains an elusive challenge for engineering. It also presents a difficult challenge for the conventional economic worldview conditioned by fossil energy, which holds that land is a substitutable resource. The global prerequisites for the Industrial Revolution, illustrated by how the expansion of steam power arguably implicated slavery, now that's a whole other set of theories as well, suggests that the new system of appropriation, which in the late 18th century began generating the abysmal inequalities we see today, is the very symbiosis between money and globalized technology. Such technologies are clearly tantamount to a displacement by means of unequal exchange rates on the market of work and environmental burdens to groups with less purchasing power. What is locally feasible is thus contingent on the rates at which embodied labor and other biophysical resources can be imported from elsewhere. This symbiosis of money and technology underlies, for instance, the capacity of contemporary financial transactions to propel physical production processes based on unconventional fossil fuels extracted in North America from tar sands or through fracking, regardless of their very low energy return on energy investment, the EROI. Another example is the claim that the photovoltaic energy, although also low EROI and subsidized by fossil fuels, is becoming economically competitive with fossil fuels, an assertion that is in part based on the reduction of labor costs derived from shifting production of solar panels to Asia. The investigation of such relations between market conditions and technological progress can only be pursued by considering trade as flows of biophysical resources rather than merely as flows of exchange values. A central implication of the EOE perspective is that the fossil fuel economy was neither created nor is being upheld by humankind in general, and that intra-species inequalities are part and parcel of contemporary history and cannot be ignored in attempts to understand it. Yeah, cocaine bear. It is arguable that the technological breakthrough represented by James Watt's steam engine might not have occurred nor proven so widely useful if there had not been great global demand for inexpensive cotton cloth among West African slave traders and American slave owners. Slavery, slave plantations, and the triangular trade between Europe, Africa, and America were the foundation for the Industrial Revolution in several ways: by creating demand for its products, by providing cheap labor for harvesting its raw materials, and even by offering the plantation as a template for the organization of industrial production. Most importantly, the Industrial Revolution was contingent on market prices determined by processes in the 18th century world system. This conclusion coincides with, I guess it's Andre Gundar Frank's Greek conceptualization of technological development as a world economic process, which took place in and because of the structure of the world economy system itself, Wallerstein. Robert Marks, Marks, has succinctly summarized this global perspective on early British industrialization: the ability of one part of the world, in this case Western Europe, led by Britain, to escape from the limitations of the biological old regime by tapping stored sources of energy, coal and then oil, was contingent and came about as a result of a global conjuncture. Technological progress, in this view, is not merely a matter of innocent breakthroughs in engineering, but of devising new and profitable systems for displacing work and environmental pressures to other populations and geographical areas. To thus rethink the history of technology necessarily also means rethinking global environmental history. The geographies of extraction and accumulation are determined by the trajectories of the world system. To the extent that transformations of ecosystems and landscapes in the past and present can be understood as imprints of global processes of EUE, this requires renewed efforts at integrating environmental history and social theory. After Britain repealed its protectionist corn laws in 1846, the increasing imports of grain to England reflected lower production costs, including land rents and wages in Prussia and North America compared to those of England. The modern outsourcing of many kinds of production to China follows the same logic. To assert that the relatively low wages and land rents of 19th century Prussia and 21st century China offer these countries a comparative advantage in world trade could be regarded as a euphemism for other countries taking advantage of their relative poverty and relatively lax environmental legislation. Since the days of Ricardo, the language of free trade has promoted the displacement of both work and environmental loads to less affluent sectors of the world system. It continues to justify patterns of world trade that result in deepening inequalities in some of the most important sources of greenhouse gas emissions, such as industrial agriculture, deforestation, intensified export production, and global transports of bulk goods. The 19th century British shift to fossil fuels as a source of mechanical energy fundamentally transformed the conditions of economic rationality. It relaxed the ancient imperative to extract energy from, firewood, charcoal, and fodder for draft animals from the surface of the landscape and generally reduced the significance attributed to land as a factor of production. Ricardo concluded that the three factors, the trinity, land, labor, and capital, were substitutable so that, for example, a British shortage of land could be compensated by an abundance of capital. This observation was based on the experience of the Industrial Revolution, but it did not raise any significant concerns regarding the global implications of locally substituting capital for land. As the repeal of the Corn Laws illustrated, however, the appropriation through trade of the products of other people's land, other nations' land, is tantamount to environmental load displacement. The ecological relief which fossil fuels and imports of grain, timber, cotton, sugar, and other colonial produce granted to Britain represented a geographical space several times the total land area of Great Britain. Now, while historical research shows that fossil fuels and imports of embodied land converged in making European expansion possible, it does not pursue the implications of the fact that the use of fossil fuels in the export production of industrial products was what made the expanding imports of embodied land possible. From this perspective, industrialization can be rethought as a strategy for appropriating, through the profits derived from exports, access to eco-productive space elsewhere in the world system. Calculations of ecological footprints and other measures of environmental load displacement confirm that similar strategies have continued to be fundamental to economic growth and technological progress in core countries for over 200 years. Viewed in this light, capital is land and labor appropriated elsewhere. The growing emphasis on commerce and accumulation since the early modern period reflects the increasing significance of money in the European merchant states of the time, in contrast to the largely agrarian societies of medieval Europe. The Genoese, Dutch, and British trading empires thrived primarily through the accumulation of money profits. Whereas agrarian societies were predominantly focusing on harvesting solar energy through crops, livestock, and the labor of animals and draft animals, of humans and draft animals, mercantile societies shifted focus to the management of money. This is Italian banks again. Although modern concepts of energy did not appear until the mid 19th century, humans have no doubt always been intuitively aware of the vital significance of the sun and what we now refer to as photosynthesis. The growing preoccupation with money did not represent a liberation from the dependence on these vital flows of energy, but a new strategy for gaining access to them through expanding purchasing power. The money accumulating in Europe provided access to vast solar-derived resources on other continents, including farmland, forests, livestock, game, fish, and not least human labor. Money can thus be viewed as a kind of fictive energy. Money can thus be viewed as a kind of fictive energy, in the sense that it is imagined as a vital flow that nourishes society. Although Marx understood the machines of his time as devices for exploitation, much of his writing suggests that he believed that they could be extricated from capitalism and made to serve the proletariat. Now, this is a paradox because it means that the social theorist who taught us to understand how artifacts in capitalist society tend to be fetishized, that is, to represent social relations as if they were relations between things, was himself suffering from the illusion of machine fetishism. Both mainstream and heterodox conceptions of technology tend to relegate the responsibility of its various political and ecological consequences to its misuse by corporations and politicians. There's a widespread belief that technology as such would not have to implicate injustices, and that this purified conception of technology can be extricated from political context where it is used to generate social injustice, ecological degradation. This belief in a decontextualized, transcendent, and emancipatory science of engineering has been fundamental not only to mainstream historiography, but also to classical Marxist visions of social progress. Fully automated luxury communism. Up until the Industrial Revolution, the periphery of the colonial world system was a source of embodied land and labor for the European core. The Industrial Revolution transformed the character of world trade and the organization of European society. The shift to subterranean inorganic energy sources alleviated much of the pressure on European land for firewood, charcoal, and horse fodder. But industrial Britain remained dependent on its colonies and former colonies for land, labor, and increasingly also materials. Land in the periphery continued to be used to provision the core with food energy, such as sugar, and materials, such as cotton. And both kinds of production required vast inputs of labor. The substitution of subterranean for organic energy was understood as a stage for inevitable progress towards advanced technologies representing a liberation of labor and emancipation for the land. Steam technology was perceived as a breakthrough in engineering regardless of the world market prices of cotton, African slaves, and American land. It was understood as the product of European ingenuity rather than as entwined with the global processes of EUE and accumulation. From the perspective of EUE theory, 19th century perceptions of capital and new technology as substituting for labor and land represent a local outlook rather than a global view of social metabolism. So what does this all give to us? The conclusion. Finally, this 19th century perception of technological progress continues to frame deliberations on energy transitions in the modern world. From the start, the reliance on fossil fuels has been accompanied by concerns regarding their finiteness and their detrimental environmental consequences, which has stimulated a succession of visions of more sustainable energy technologies, hydroelectric, nuclear, biofuels, wind, photovoltaic, and so on. After over a century of such technological visions and development, however, around 85% of global energy use continues to be fossil. Yes, it is. And the use of fossil energy shows no sign of diminishing. We use the same amount of coal as we did a decade or several decades ago. The coal use has not declined. Considering the thoroughly globalized supply chains that characterize the modern world economy, this means that 85% of the energy used to produce and maintain the infrastructure for both nuclear and renewable energy technologies is fossil. The close connection between energy use and economic growth is well established. Although concerns regarding climate change are alarming, there's little indication that the global political establishment, by and large, is seriously committed to abandoning fossil fuels. This constitutes an impasse, not only in terms of the aggravating contradiction between economic growth and sustainability, but also in terms of our theoretical understanding of technological progress. The acknowledgement of EUE can help us widen our concept of technology to include not only the requisite achievements of engineering, but also its dependence on global exchange rates, such as fuel prices, rare mineral prices, labor costs, and land, under which market circumstances, for instance, is it feasible to propel European cars with sugarcane ethanol from Brazil or batteries based on cobalt mined by child labor in West Africa? A fundamental implication of EUE research is that globalized technology is a thoroughly social phenomenon in the sense their feasibility is ultimately contingent on discrepancies in the relative prices of labor and land in different parts of the world. Their underlying rationale is the strategic displacement of workloads and environmental loads to less privileged groups in global society. If such a dependence of sustainable technologies on global rates of exchange can be demonstrated, a dependence of sustainable technologies on global rates of exchange can be demonstrated, the implications for a green transition are deeply disturbing. An observation associated with the EUE perspective is that the acceleration of entropic processes such as resource depletion, pollution, and greenhouse gas emissions largely derives from the intrinsic properties of general purpose money, which continuously reward an accelerating dissipation of resources with access to ever more resources to dissipate. If conceded, this conundrum could be expected to prompt various suggestions on remedial policies. And he talks about his other stuff and to ameliorate the destructive inertia of the world economy, I argue the design of the muddy artifact itself must be considered with the reach of increasingly globalized market transactions curtailed. Now, while perhaps naive, such subversive lines of thinking are thoroughly justified by the predicament of the Anthropocene. Even though much of the expectable cognitive resistance to the argument on technological fetishism undoubtedly derives from the seemingly impossible prospect of offering a solution to the problem of EUE. It must be reasonable to define the problem as an analytical task separate from that of devising a solution. In other words, acceptance of the problem definition should not be contingent on the feasibility of a solution, which, the ball gets punted in that particular context. Ecologically unequal exchange. And lest you think that's unimportant, this is like this is the tip of the spear for discussing at least energy transitions in the current day, because of this problem of reliance on fossil fuel to ensure the development of renewable, sustainable energy. And the fact is, we're not doing it fast enough, and it's just you know it's because of capitalism. Okay, so I'm done with that. Let's see if there are comments. Brickbats at all? Not too many comments. I put Anna L to sleep. Uh, I drove Sharon away. And whatever. So I'll stop share. Stop